Hi, good afternoon, everyone. I have a dedicated topic for you that will revolve around the marketing risk, and I'll just give you a brief about the case study also that we are going to talk about, and a brief idea because as per my understanding, like I gone through your what are the courses you have take up, and then kind of what kind of batch mix you have. So I understand that this is a diversified the sort of group, and you must be carrying the background from engineering and some of the management also. How many of you are management graduate? Okay, good. And how many are engineers? Okay, and how many are from mathematics or statistics? Okay, you studied what? Stats? Okay, and yours? Statistics? Okay, wonderful. So you can understand that the area of analytics is as diverse as your batches, and it can be even more than that. I'll try to cover a few of them. I'll just give you a quick brief about myself. So right now I work as a Deputy General Manager for Mahindra. I head the data sciences there, and before joining Mahindra, I worked for some of the data sciences company. How many of you have heard about EXL? EXL? Okay, a few of them. I work for Absolute Data Research and Analytics. I work for dunnhumby. Dunnhumby is again a retail science company, and a couple of again telecommunication company. In terms of my exposure, like I started my career into the drug discovery process. So when you take any medicine, it has to go through the various statistical analysis, which tests that how is the survival effectiveness of with the existing new molecule that you're discovering, and what is the safety and effectiveness of it. Later on, I work for some of the banks like Barclays in commercial risk analytics. I work for then retailers, like doing some of the promotional campaign effectiveness analytics, and how we can have the better coupons for the higher redemption of the coupons. And later on, I work for a couple of consulting firms. I work for Dell in the marketing analytics, and I work for some of the e-commerce company named as a Snapfish. I work for Airtel Bharti Airtel as well into some of the marketing analytics projects. So, and I work for the insurance for American International Group, AIG, in the loss ratio prediction. So now you can understand that what can be the analytics and how many areas can be, right? And then currently I'm working for automotive, and I never worked for automotive earlier before this assignment. So my here job was to principally set the data sciences team for them. And as you know that it's a very, very old organization in India. So definitely now they're very much keen to adopt the new way of doing business and their decision making. So I got inducted here. This is a centralized function which captures the analytics services to the automotive, farm, agriculture, which is out of $17 billion. It is $11 billion of M&M Group, which has around 20-25 companies. So now you can understand within Mahindra also, you will have many diversity. So now what I want to conclude is you are going to solve the problems across the industry. So you should have the ability to connect data with the business problem, and how you're going to devise the your statistical or mathematical understanding to bring the efficient decision making for the business. In terms of my education, I graduated in mathematical statistics from BHU, and then later on I did my management from Indian Institute of Management, Kozhikode. In between, I tried studying more about stats and maths at Chennai Mathematical Institute, where I dropped out after a year. But it is again interesting to learn some of the theoretical part of it, and it is very exciting. In terms of my, again, the other hobbies, or you can say that the activities, I interact with people, very bright talent like you at various institutes. Mostly I lecture to the professors, and at some of the forums I interact with the students as well. So again, this adds value to me by understanding what is the talent and how we are going to, because in the past 10 years, the career where I started and today where we are, it has a very diversified journey. Nobody was looking at the stocks before buying the stocks at sentiment score, but nowadays at the money control, you can see the sentiment scores, right? The kind of technology we were using at that time, the kind of concepts, the kind of, at that time there was no, the talks around something called the machine learning and kind of, but there were a lot of traditional ways of solving problems, but nowadays it is flooded with, and that is the reason like you are also trying to study and get more command around it. So that's in a brief about me, and I'm just going to take you on some of the quick. This is a PPT version. This is a PDF. So how many of you have gone to Nasik? So last week I was at Nasik. Last week I was at Kerala. So I can just connect your analytics with my vacation. So how many of you have done the wine testing? Right? So this is the in general way, right? They tell you that look, smell and taste, isn't it? And then you say, how many of you said fantastic, I loved it? How many of you? Okay. You didn't like the taste? Yeah. Okay, yes. So this is a slide I picked up from one of the economists from Princeton, and this was my first book I read when I passed out my graduation, and you should read about it. It's a book named as Super Crunchers, and it's a very good literature on how analytics have been used at the very long and old time as well. So imagine that a lot of people, like we have a wine tester, but this particular economist, he was trying to fit an equation to predict the taste of the wine. And as you can see the equation in front of you, that what are the factors. Even though this is a very curtailed version of the equation, and there can be, I'm sorry, there can be many detailed, variables also included into this model to predict the right set of the vintage. What will be the taste of that vintage basis the mathematical equation. So now you can understand that the rainfall, the kind of humidity, the kind of the temperature of that particular vintage is going to decide what kind of fruit you can have, and that is the ingredient of your wine, and basis that you can predict it, right? So initially people find it very crazy that how can you test the equation test the wine using regression model, right? I would have shown you a little more way, because there's no animation, but it is very funny when people talked about that testing the wine basis a statistical equation, right? So again, what I want to say is yes, it is possible. So now, can you break your limit to think about solving a business problem using the statistics, right? So I was never able to understand before getting the solution of it that, hey, I can use my regression model to predict the taste of the wine, and basis that even the prices of that particular vintage, because you must be knowing that some of the particular manufacturing year vintage has a specific prices. Some magic happens when the wine gets older, isn't it? So like that. So now, I'd like to take you on what project that I'm going to talk about. There are many. I'm going to cover one of them, which will give you the good idea. And I know that you have not read a lot of things on the predictive model at this point in time, right? But you have to just jump in your, again, imagination. Try to capture what are the things you can have certain levers from here, and then you can relate with your subject whenever you're going to learn it. So this is a problem I was solving again for the rural markets, and this is very interesting because in country like India, applying analytics something for rural is interesting, because I have been applying for banks, for retailers, for telecommunication, everyone, but this is the new area that I was trying with. So rural market, again, it's a very large segment in our country, and now think about the companies like HUL, right? Think about the Tata Beverages, or think about many companies. I was just addressing a group at Westin, which was on Rural Marketing Forum. It's a very well-known forum there. So it is a large segment of our market, and what happens that when you place a lot of business works on a model that you place the inventory to them in advance. Like you give them certain period to pay you back, and you give the inventory to the dealers to do business. Right now, there's a risk associated with it that if the dealer defaults, it's a damage to you, isn't it? Like there can be default and there can be damage. So now imagine that you are a owner of 200 crore portfolio, and you are responsible for developing this market. Developing means building the networks, like the supplier networks. And the second is what product you're going to allocate to those respective dealers. right? So you will have imagine that you have a 60 to 70 product portfolios, right? And imagine that you have around 4 to 5,000 dealers, and then and each product has a different profitability for you, right? So you need to place your product portfolios to the different dealers, and there the way of the business is you have to place the inventory on their credit basis, right? So now, can you think of using certain analytics that can you think of some damage which can happen when you do not have any predictive modeling, and what can be the effectiveness when you have the predictive models? So can any one of you quickly just tell me what comes to your mind, what can be the risk and what can be the thought of using analytics to help this business, right? This is I've given you the entire context almost. You can ask me a question if you have any. So how many of you think that, means placing inventory without analytics can be riskier? Okay, few of you and almost all of you think that. Now, my question is that what we should do to know that how we can minimize the risk, because, means there can be the demand at certain places. So there are two kinds of problem associated with it. One, let's say the demand of certain product is with this set of dealers, but I have placed some other set of product to this dealer to push and you know that there are the certain seasonality also involved when you do certain businesses, right? So if your allocation gets wrong, that is another risk, right? Means even though the dealer might have the good potential to sell, might have the good potential to pay you back, but because of your inventory allocation to the different dealers can damage your entire, and it can block the entire supply chain, and it can have very high inventory for you, which can cost you a lot. And the second, the place where you needed certain inventory, you may have the missing, availability of stocks at that time, and that can again damage you, right? So this is a very, very a relevant question to the topic. I'll tell you, especially because I'm solving the problem for automotive and some fields like this. So it is a very, very, you can understand that when your ticket size of the items are large, for example, of vehicles, right? So it's 1,000 crore inventory mismatch, and the kind of, you can have more than 40 days inventory available, which should be ideally not more than 15 to 20 days in terms of the management thought. But with the wrong allocation, it can be 40 days of stock inventory can be mismatched, and which is in terms of the automotive, because it's a large ticket size, it goes around 1,000 crores of inventory misallocation. And that hampers not only the kind of the demand at the field, you may not be able to provide the right set of the product to the customers when they have the certain demands. However, so again, it is relevant with the size of the business, and I have given you the calculation that it goes, especially in the case of automotive, around 1,000 to 2,000 crore minimum misallocation of the inventories. So now you can get into the revenue of the entire, it's around 15% of the entire revenue that you're transacting in a month, which is a huge amount for you. It's a big, very significant, and it's a major problem for any sales planning team to place the kind of the right inventory at right place to mobilize the goods. So now this is the risk number one. The second risk is, even though you might have done the right allocation, in the best case, you might have placed the inventory to the dealers, they might not have the right ability to give you money back because of they are not able to sell their product, right? So this is another so these are the reasons why dealers will land up in defaulting with your money, and then that will suffer and damage your entire business. Now think about what is the analytics solution that you are going to provide them. So now these are some of the generic things, like you can do some of the secondary research, you can do some of the focus group study to understand the market landscape, and you can try having some of the right strategy for them to allocate the product. Now just think about, even though you have this framework, but you may need certain advanced tool which can help you in designing your supply chain and designing your how much inventory you're going to place with the different dealers. So now I just want to give you an overview that what are the sort of analytics that you're going to take up to perform this. Now, you have your problem in hand. I have given you some sort of the analytics, right? And this is a ladder I have plotted from the A's of doing analytics in terms of the cost and in terms of the skills required. Now, let me ask you, how many of you can do summarization of the table? Almost every one of you. You must have worked on certain Excel sheet. So this can be worked as either descriptive or diagnostics analysis, right? And I hope you must have done something like this, right? So now you imagine the any form of a car. So this is something like a rear view of your business, where you can see that what has happened in the past, and basis that you are trying to take certain decisions, right? But parallelly, is it sufficient to take the right decisions? Right? So then the role of your advanced analytics comes into the picture, and then you relate it to that you want to do certain predictive analytics, and either you want to do certain, basis the predictive, you want to do certain prescriptive consulting to your business stakeholder. Now I'm going to ask you that, let's say we have a descriptive and diagnostics which has given me the what has happened in the past, but what is going to happen in the future, and basis that if we are going to design certain algorithms, certain models that can help me in taking the right decisions. Isn't it? Do we agree with this? Good. So now my question is, in the descriptive you might be calculating mean, median, mode, standard deviation, skewness, kurtosis, right? But what we do in the predictive and prescriptive? Prescriptive is now basis the prediction you want to prescribe to the business that, hey, you should do this, A, B, C, D, 5 things, right? So my question is, let's say like now if I want to have, and I have just plotted it in the value that it can bring it to your organization and the level of difficulty that you have in performing. So there your skills come into the picture, that whether my resources, analytics resources, have the ability to predict my business scenario. Will they have the ability to give me the recommendation on my problem statement, isn't it? So now I have just mentioned that what can be the different scenarios in terms of if I want to do the predictive. So tell me one thing about the predictive. What are the things you want to predict? Now you know your problem statement. Give me the idea that what you want to predict now. What will the demand? Second, this is the first part of the problem when you have to do the inventory allocation to them. Now the second part is who is going to default, isn't it? Now I'm going to ask you the question, what we should do to predict that who is going to default. So let's say you have now, we have learned that, hey, if I can have two types of prediction, one, what is the demand that this market is going to have, basis that I can allocate the right product portfolio, right? And the second, who are the dealers going to default? If we know these two answers, can we handle our business better? Yeah. So now you have to solve these two problems, that how you're going to predict the demand, and the second, how you're going to predict the riskiness of the dealers or the riskiness of the market, right? Now, help me. Now you all are analysts. You have to tell me that what kind of model you will build to do these predictions, right? And at the end of the session, we are going to conclude this with this learning. So now I'm going to quickly touch base with you, because I have given you the problem statement. I have given you the idea what you have to bring to solve this problem, right? So now this is the life cycle of the entire your analytics solution that you're going to provide. It is very generic. It doesn't matter what problem you're solving in analytics, but you have to follow this route. So one is the assessment of the data, right? So identify that what are the different set of the variables we can use, right? It can be certain internal variable, it can be external variable. External can be outside your organization, right? Internal, what you are transacting within your organization, isn't it? So this is assessment of the data. Now, how many of you know, and how many of you we can understand that the data we have, but data just availability is not going to give you the solution, right? We have to give a shape to that data to build any model, isn't it? So you need the exercise that is going to help you to prepare the data, isn't it? And what comes into the preparation of the data? The one, definitely like you're going to clean the data, right? Because the data will not have always the way neat and clean form. It can be structured and unstructured. You're going to create the framework for the data. You're going to do some of the missing value treatment. You're going to do some of the outlier treatment, right? And what is the outlier? You all know it, right? So you have to do the treatment, but what treatment you will do it, that you can learn in detail, and it's a very good exercise to do. Now, once you have the data prep done, then this is the next step you will have to do is model planning. So like in our kitchen, you get many utensils, right? You get many instruments to make any dish. Similarly, in analytics, you will have many mathematical and statistical equations to solve the same problem, right? So selecting the right method is going to be the next exercise, isn't it? Now let me ask you that what is the difference when I said mathematical model or a statistical model? So now let me ask you. So what I'm going to talk about that when you build any solution, you will always have estimation errors, okay? So mathematics is about absolute numbers, like it is 2 plus 3 is equal to 5, but let's say y is equal to 2x plus 3 is a mathematical equation. But when I say that y is equal to 2x plus 3 plus epsilon, which is representative of error, means epsilon can be anything. So he will not say 2 plus 3 is equal to 5, means he'll say 2 plus 3 is equal to closer to 6. Can be, right? So now let me give you the context. So let's say so stats is little flexible. It gives you the scope of accumulating certain approximation errors, and whether it is good or bad, you have to just discuss. I can just give you, we can contextualize that. Let's say there was one girl, and she was proposed by a mathematician and by a statistician both at that time. So can you guess whom she preferred and why so? Is it? Okay. So when a statistician says, I love you, he doesn't mean it, that is I love you plus minus error. Isn't it? When mathematician says that I love you, he means it. Then, so exactly, you want mathematician, right? But again, as you said, he's very particular or she's very particular about everything. I want my breakfast at 5 means at 5. If you're doing 5 plus minus, I'm not happy with you and something like that. So what I want to conclude is that, means when you select the models, you will have always some of the scope to accommodate certain deviations, and which model is going to give you the best projection. That is a very, very crucial exercise, and you need tremendous experience to do that. And basis this, I'm going to tell you that entire business decision is going to focus, if my organization is analytical in approach, my entire business decision is based on what my the analysis is going to set. There's no gut call, right? Means a lot of businesses that happens that he is a friend of the Burmaji and Burmaji has given the recommendation, push more inventory, right? So Burmaji will not be responsible for in the last when there is a default on the dealer side, right? So what I want to say, there is no manual overriding, and you have to have decision on what your equation is saying. And if your equation is bad, you imagine that you're going to damage the entire game in the business, right? So that is why the model planning is very crucial. Once you have planned the model, you have to do the model building exercise, which is again, I'll tell you how is the life cycle on that. And then you do the communication of the result. So imagine that I convey to my business owners that, hey, I have applied machine learning, artificial intelligence, support vector machine algorithm to solve this dealer risk. He'll kick you out because he doesn't understand. He wants that, boss, paisa kisko dena hai, paisa kisse lena hai, and saman kisko dena hai, tell me that, right? Isn't it? So now you should have now you cannot talk like what you will learn in the classroom. You need to know how to simplify those equation and the predictions, which can be translated into the business language. And that's how we do it. Once your model is freezed, it should be operationalized, like it should have a monthly refresh cycle. Either it should be fortnightly basis the complexity of your business. And then you're going to again have a generation of the first set of the results when you are taking the analytical models. And there will be always misclassification. Means, what do you mean by misclassification? You will be false in saying that, hey, this particular dealer is going to default and he may not default. But this should reduce with time, and that's how we call it. You should have a self-learning algorithms, and we try to build on and improve on that. So again, this cycle starts, you assess the data, again you do certain tweaking and you try to improve it. So now, specific to this question, that we need to again integrate the many sources of the data, and I'll come in detail that what are the different sources of the data we want to have. So now I want you to read what you have concluded basis our discussion, that this was the business scenario. I have just calculated now to build this equation, build this kind of prediction, the riskiness. And do you know that you are building this kind of model? This is the 70% of the exercise. If you master this, you're going to survive 70% of time in the industry. What do I mean by that? If you join any analytics firm, if 100 clients have come, you can solve the 70% clients problem using this approach. What do I mean, and how I am saying this is like this. I'm sorry? See, I have mentioned that it's not for circulation, but you can just make. Okay, this one. You will learn it because what I have learned in my life, I think this is like I talk very often to the institutions and people, so it will be a very simple language. You just make a quick note, you will be able to grab everything. Yeah, so what I was saying, 70% is, imagine in the banks, what happens that when you give the credit card, whether the customer will default or not, isn't it? What happens in marketing? If you are sending 100 campaigns, like 100 or the 100,000 people you have taken in your campaign, how many of you are going to convert, right? So whether they will buy or not, it's again a binary. This is also binary. Who will buy, who will not buy, who will default, who will not default, who will win, who will not win, and what else? You give me any example. In telecommunication, who will churn, who will not churn, right? Who will survive, who will not survive. So if you know how to solve this classification problem of binary types, which is again a very, very simplest, which is the 60 to 70% of the business problem, and just your variables are going to change, but you will be able to frame your solution and you will be able to work on it, right? So what I have done now, if I say that people who are going to default is I'm marking them as 1. You have done some hypothesis testing. Okay, so who are defaulted is 1 and non-defaulted is 0, right? So whom to call defaulter? So first, whom to call buyer, right? So that definition you have to make it. So here I have taken a cutoff. Like if the person has not paid me for the, let's say 365 days or 180 days, I'll call you as a defaulter because I have given you a certain inventory and I have given you certain period to pay me back, right? And let's say the small amount, let's say 100, 500, 5,000 rupees, I'm not worried about, but I have a cutoff that if you do not pay me, if my pending amount is 10,000 and more than 180 days with you, I'll consider you as a defaulter. So that definition has to be clear. And as one of the gentlemen said that, we need to know who have defaulted in the past. So there are two types of model. You must have heard, one the supervised learning and unsupervised learning, right? So this is a problem statement of supervised type, where you will have some of the past incidents and basis that you have to train your model to predict the future default behaviors, right? So you will have some of the 1 and 0s, okay? And now, basis that, you will have their set of another explanatory variable to do the model building. Now, what I want to do, what should be your deliverable as an analyst is one segment of dealers, like basis on high risk, low risk, and this method not only can solve where is the high risk, but where you should do business, right? If I know that this set of people are, this group of people are high risk, high in risk, I should select the low in risk and I can improve my business better, right? So this is the inherent benefit of this. And then again, giving some of the insights which can help you to understand that what kind of factors are responsible for a dealer. Like she was explaining that, maybe the rainfall, like bad rainfall in certain district can, or certain reason can lead to the default of the payment, because can be the reason, right? Because the entire economy can get hampered. But again, this is again a area to test. Now I'm going to talk about something very sensitive, and this is very important, because whenever you do the development, you need to do the requirement gathering way in detail with the business, and they give you a lot of hints that you will be able to get your set of variables which can be useful for you. For an example, the dealers in past who have defaulted on the payment, not defaulted on the payment, but whose checks have bounced, or you can understand that who has always taken a longer duration to settle your payments, like the length of or the frequency of payment in a month, kind of. So again, these kind of variables can be created. It is not a direct variable in your model, isn't it? you have to do a lot of derivation of the variable with the existing set of variables, right? So let me now give you the problem. You all have, like mostly you must have certain workx, right? So can you give me what are the information captured into the transaction data? So what I want to say now can be set of 15 to 20 variables, right? But now your analytical agility is now responsible for accuracy or the high-end building of your model, high-end modeling exercise. Now you can create around 500 to 600 variables by this just 20 variables. How? Like one, I can calculate what is the frequency of your purchase. Let's say imagine a big bazaar kind of shop. How many times you come in a week or in a month, and I can decide that. What is the ticket size of your purchase, right? What is the average size of your purchase? What is the distance between the two purchases you have, right? How many purchases you do, right? What is the average transaction which I talked about, right? What is the specific slot of your purchase, like morning first 4 hours, mid 4 hours, or the last 4 hours of the business day, kind of. So I'm just giving you the hint. And these are the variables we should derive. You know, what happens by this, that it may be that direct variable may not be the very prominent indicator, but some of the derived variable can capture the trend of the default or the purchase with respect to your explanatory variable. So now what I want to conclude is that you should have a very rigorous discussion with business to do the derivation, and we call it as a the analytics data mart also, to create before building the model, and that's how I said data prep. And it should be very well done with the business and whosoever will be your consulting engagement from the business side, and then you will be able to translate the entire analytical view in terms of the business information. So that's what is very important, and you should take care of it. Now, specific to this entire the dealer risk prediction or the risk prediction, we tried considering what is the capital related variables that we have, like what is on an average dealer does the transactions, and what is the type of the product portfolio he or she has, and then what is the capacity, what is the condition, and whether they place any collateral with us or not, right? So this is the set of variables, and these are the just set of the areas, and under this you can have around 20 to 40 variables, and basis your maturity of the organization, you will be able to build the different set of the information. What I want to say is you should have this understanding that higher the organizational analytics maturity, lower the time in data preparation and kind of building the model. So what happens that, let's say if I take 100 hours to build my predictive models, then imagine how much time I am going to spend on data prep. Can you give me the rough idea? So let's say I'm allocated with 200 hours of my project to do the solution for this. So how much time I should spend in data prep exercise? So this is the entire life cycle of data prep, model planning, building, results, and how much time you should spend where? On the data preparation, 70% time, 50% you should give on data prep. Okay, and then most of the time we have to quantify. We are analysts, so around 70% or whatever the number you're saying. So what I want to say is, in general, the time and effort that is going in the data prep, right? Ideally, I should spend more time in building the insights, right? And I told you that you will have a set of model to do this. Imagine that you spend 70% time on data prep, and remaining 30% time means you will have a very contracted time, or the kind of very less time in experimenting that which kind of model is going to give you. And I told you that you will have thousands of models to solve one problem, right? So it is very dangerous, and especially why I have written this line. See, this is the first organization, an Indian organization I'm working with. Mostly we worked on, I personally worked on the US, UK market, and they were very high end in terms of their data creation, data quality, at least in the banks and retailers. Maybe e-commerce again, like in the social media and all, the data will be very, very unstructured, and you need to do a lot of cleaning before building the model. So when you do the effort estimation in terms of data prep and the modeling, we should always estimate our time and effort basis what is the standardization or what is the quality of the data you have. Because if you spend very less time on the model building, you may come up with a very suboptimal model, which may result to very again suboptimal decision making. But it is again true that if you don't spend too much time on the data, then garbage in and garbage out equation will come, right? So again, we should have a balance, and when you do the kind of any project, you should have the idea that where is and what condition you have in the data and how much time you will need to prepare the data for your model. And it's very important because it is going to impact the model quality, your deliverables and everything. See, in the best case, you should not have more than 30% time on the data prep. Around 40-50% time you should have building the good model. Again, with including the communication of the result is equally important. It doesn't matter, you must have built the world fantastic model, but if your business is not convinced, tomorrow they'll stop putting money with you and they'll say that I don't want you to think about my business, I'm happy how to do my product to sell, right? I know who are my risky dealers, right? So communication and the realization of the business value is equally important, and it should get buy-in. It should sync with the what business is also experiencing in the field, and basis that it should not talk a different language, right? If it is talking different language, something you have done wrong in your exercise. Okay, so now I'm coming to the part where we all have to think, because this is very straightforward. I have given you the answer, but what you need to learn that whenever if I just exclude the slide, like let's say if I don't show you, and I have already talked about the set of the variables. Now you think that you're not solving this rural market problem statement, you're solving the problem statement for who are my customers in the credit card company going to default, right? Or imagine in terms of I am doing a campaign that who has bought my, let's say, this server and who are going to buy my, let's say, security softwares. These are my customers of servers. I want to sell now security software, so I want to do certain cross-selling of my product, right? So again, this is a binary problem 1-0. That's why I told that you will be able to solve 70% of the problem. So now think the set of variables. So now I want to just answer it quickly, that we will have a set of the variables which may come up from different context, and in general if you try to classify anything related to transaction will be there, but there will be only original set of variable that is in your database, but the remaining you have to do the derivations, right? And that you know how to derive these variables. Now on the demographic side, specific to this dealer, this problem statement, a lot of the human resource based data when the people are in the role, maybe like the collection strategy of my the managers are not so strong, right? Maybe he or she is less experienced, maybe less experienced and less experience in that particular role it is. Maybe overall experience is higher, but less experience in that role, right? So you got two kinds of variables here, right? Total experience of the resource, right? Who is working in this field, and then how much experience he has or she has in the managing such transactions, right? So this is what I want to highlight, that the variables can be as varied as possible. It can be in the internal sources, it can be in the external sources. Now how was the performance of monsoon? How is the policy of the different bodies in that area, like banks, like the government, like many non-banking financial services, especially if you talk in this scenario, right? And then even what is the cropping pattern, what is the soil quality, can be the other indicators, right? And what have been the competitors penetration in the market, that can be other flagged variables, and these are not the variables that will be just available to you, right? You have to prepare these variables. So that's how sometimes the exercise is very tedious, because means in India when you try capturing let's say like the rainfall prediction, I want to have rainfall prediction, there may be the few points where we can have few locations where it can be very good, but my modeling granularity is at the dealer level, right? So in one of the city I can have many dealers, right? So what should be my granularity of external variable while I am building my analytics data mart, right? Because data mart will be like for every dealer there will be one record, right? So that way in this scenario you will have 5,000 records, And for that dealers, you will have their transactional information, like how was their purchase behavior with you, what was their payment behavior with you, what is the cycle of payment, what is the amount of the payment, and so on. And then what kind of even demographic factors involved with it, what is the cropping pattern, soil quality, and so on you will have. And similarly, now you can keep on what are your policies you are capturing in terms of the early payment and kind of the efficient collection of the money. So now I'm going to ask you two problems again. One, this is the scenario where we are solving once we are transacting with the dealers, right? We are trying to predict the risk. Now, can you think of a situation where to minimize this risk, we might have done the prediction of risk with the dealers before taking them into our network? Like you must be now aware that once dealer is into your system, you must have done certain acquisition exercise as well. So can you do a similar predictive model before acquiring that dealer into your network, right? So what I want to conclude that there can be at the many stages that you can do the risk prediction, and you can and let's say I want to open certain business venues, right? Means maybe if I'm working as a dealership, either I work as a branches of bank. So where I should have, if I have the 5 locations, then which other locations can have the higher benefits to me? So even those kind of analytics are before doing this kind of predictive model when you are transacting, and this is ahead of that. Now, so I have just talked about it. So this is a typical exercise that you do to build such predictive models, which is going to give you some of the model building criteria. So as you can understand that I have just written 1 to 3 weeks, and again the number of analysts can vary, which can take up the activities like missing value treatment, outlier treatment, what is the bind variable creation, and what is the training, test, and out of time data creation. So again, as we talked about the life cycle of the project, this I just want to connect you that when you want to do the exercise, in general, you will be, when you will work, you will be given such similar timelines to do these activities, and you need to learn the kind of concepts that how you're going to prepare the better data mart to build the good models, right? So what I mean by bind variable means many time, like let's say my transaction amount is a continuous variable. Now I'm just going to talk about a little bit about variables, how we decide and how we prepare those analytics mart. So let's like my transaction, and imagine that we all are customers, transactions can have certain value, and converting our transaction. So for an example, let's take our weight. So how many of you think that if we plot a frequency chart of our weight, we'll have more than 2 frequency? Let's say I'm measuring your weight into the next 2 decimal, 2 places of the decimal. Means I can be 71.29 kg. So if we get our weights calculation, no, 0 will not be, there will be at least 1 frequency, like you will represent your 1 weight, right? Means we hardly will have, there can be coincidence, but hardly will have more than 1 people same weight, isn't it? They will vary because I have said you that I am capturing. Now let's say I classify this weight into the 40 to 60, 60 to 75, 75 to 90, and 90 above. Now can you build the frequency table? So now the bind variable, so we had a variable which is a continuous in nature, and then we transformed it into the bind and the classes. So it is nothing but converting a continuous variable into the classification variable. So not only the missing value treatment and the outlier is going to help you, but you need to sometime convert the continuous variable into the classification variable as well to test that which model has the better predictive ability. Does that make sense? So these are the exercises that will go into your data prep. Now, what I'm saying that now you have to build the classification model, and classification model is another going to take 4 to 5 weeks exercise. So you can just add as a continuum as well, like 1 to 3 weeks, and 4 to 5 weeks you can have a 2 to 3 weeks exercise in building the model where so now tell me, let's say like I have a 5 model to solve this problem. Shall I try all the 5 models, or can we select the 1 model out of the 5 models? Okay, so approach can be means you might build all the 5 models and try effectiveness of the models, try checking the stability of the model, and this is again a very rigorous exercise, because let's say like if you have to build a model, so let's say like is it visible to you? This is a green color. Let me use blue. So I'm just plotting some equations, and let's say like this is my data on my axis, right? And I have a set of, so let's say this is my model 1, this is my model 2, this is my model 3, and so on. Imagine that I have built 3 models, right? And believe me that building a model is a kid's job. When you will have, how many of analytics software you guys have used? Anyone on SAS, R, how many? Okay, SPSS, okay, and Python. So again, this is a set of the multiple, your platform where you might be working. So what I mean that building the model to solve this problem, I have plotted the equations, and any one of you can build a model. But which is the good model, or which is the model that I should rely on? And imagine that this is the business equation, where if you're going to say to your business that, hey, you have to give the product of this volume to this set of dealers, you have to give it to them. And imagine that if you do the wrong prediction, what is going to happen, right? It's devastating, right? And you may be fired tomorrow if something happens, something surprising, right? You say that, use this model, this will reduce our default by 20%, and business has taken action, and then default has gone to 40%. What will happen? How will you safeguard yourself? Or you will just resign and move, right? Because the entire stake is there, and your equation is going to take the decision that, okay, like you must have seen that even the CBIL and all, they have the scores, right? And even when you fill any information in the credit card or any of the bank loan or kind of form, basis that they create a score, and basis that if you cross the cutoff, they give you the loan, they give you the credit card, or if not, then, so imagine that it is going to hamper the customer acquisition portfolio, and it is going to expose the particular business on risk, isn't it? So yeah, so what I'm saying that I have a set of models, as I said you, that you will have a set of models to try. So one opinion is that we should build all the models and we should see the effectiveness, right? So I have plotted all the 3 models, let's say for this example only 3. Then which model to select, right? So you must be now, let me simplify it. So as you said that let me try on such samples, right? So how many, if I'm trying on a sample, right? And then imagine that this is my set of the people where I have done the development of my model, and this is my set of the people where we have done the business in past, and some of them have defaulted, and let's apply this equation on them, okay? And I know actually that how many were defaulter and how many were non-defaulter, right? So model 1 gives me, now you have to just understand, it must be in my next slide, but you have to plot a cross tabulation on your paper. So I have written 1 and 0. This is the actual and this is the predicted, 1 and 0, okay? Is it visible for you? Okay. So this is actual 1 and 0. 1 means the people who are defaulting and 0 means who are not defaulting, right? So in the test sample, if let's say out of 100 people or 100%, let's say this is 10% are defaulter, let's say for an example, and my model is capturing 7 or let's say like 6. Let's say I am putting now 60, and then let's like this is the 10, and then imagine like 25 and 5, something like, and you can just, so what I'm saying, imagine like 100 here, 1000 here, and then 60 and 25, and let's say 15. Make this whatever the population is. So I have written 60, 25, and then 15 and 1000, right? So what I'm saying, now I got I have the 3 analysts, and 3 analysts will give me this kind of 3 tables, right? So out of, you can say that total number of defaulter were 85, 60 plus 25, that is the actual defaulters, right? And how many of my model has caught defaulter as a defaulter? 60. Isn't it? Right? And then there were 15 non-defaulter, 15 this non-defaulter, but my model predicted defaulter. This is wrong. We would have done business with them, but you said that don't do business. So basically they were non-defaulter, but you said that they will be defaulter, right? So for every model, you will get this classification. This is as simple as any literate person can interpret it, isn't it? So we call it as a confusion matrix. Yeah. So now you can understand that if I'm able to, some analyst comes and they can make it, let's say 60 to 70, and they can make this to 15 to 5. Okay. So what do I mean? They are able to reduce this misclassification. See, this is actually defaulter. Model said non-defaulter. This were non-defaulter, model said defaulter. Right? You got it? So this is called the, you can use it as a cost matrix also of the model. This model will tell you that if I trust this model, then what is even the damage that I can make, right? And if this damage is less than whatever the business that I'm going to achieve, we are good to use it, right? So what do I mean? The model which is going to minimize my misclassification rate, we are going to use that model. And now let me make it more simpler. So if I have a actual and predictive, the model which can minimize my actual and predicted is going to give me my best prediction, isn't it? Minimization between my actual and prediction, right? In terms of, let's say, quantitative prediction. So now this is a way, sometimes what happens when you get a long experience in certain domain, so you'll be very clear that, hey, let's make the shade model, let's make the decision tree, let's make some of the cart model, let's make some of the logistic regression model to solve this problem, when you will have a long time experience in that certain domain and the area, and you know that in this kind of field, this set of model works, right? So that's how you can minimize your time. In many cases, even if I might have worked in same areas, but data, the kind of business logic might have changed a lot, so that my particular equation which used to work might not be valid at this point in time. So it's always good that you try and test the different models, try to see its effectiveness and the kind of accuracy in terms of the prediction, and basis that you will be able to select it. So again, like you can have the model stability check, model robustness check. Maybe it is working very well on this development and this test, but when you went into the future and something has changed in the environment and it is not able to capture now the real-time events, right? Then again it will be harmful for you. So that is in a nutshell. Now I'm going to talk a little bit about, you as an analyst will always have an option that whether this solution has to be built on SAS or SPSS or Python or anything. So now help me to understand what is your exposure and how do you select tools, and then I will talk about how I selected the tool for this problem solution, which will help you in maybe like solving some future problems. So I am going to do this exercise. Have you heard about Minitab? Yeah. So yes, you have shared the right angle, and definitely you as an analyst will not have a lot of option to select it, and you will go by what functionality and where you can do the model building activity quickly. But when it is a question to the organization, and even a lot of places when I sell my solution to the top executives, like entire the leadership that I work with at M&M, so they have the heritage or the legacy to using such tools. The team have the teams in the past, they have developed solution on Minitab, so they'll come to the question that how it can aid my life, right? If my applicability is difficult, and if I'm used to developing some analysis on certain product, I'll have very strong reluctance to adopt new products, right? So, but again, basis the complexity of the product, complexity of the problem statement, and some of the functionality availability. Yeah, means again, there will be, when you will opt for your career, you will be going to the organization where the tools and everything are mostly fixed. You will be asked that, hey, do you know R coding? Do you know programming on SAS or Python, like that? But yes, when you have to design the entire architecture, you want to have a uniform product And it is nowadays, like mostly the banking and financial services, they are still on the SaaS. And a lot of small analytics or the kind of new edge companies, like you talk e-commerce and all, even though they are large in terms of the data generation, but again, they want to save costs in terms of deploying the costly products. So they want to try developing their own modules by using some good data scientists using R and Python as well, and we are able to develop that. So even in my org, like around 70-80% projects we are still doing on R, and SaaS we are using for some of the warranty analytics projects, because we manufacture a lot of products and we need to know the reliability of the products and their performance. So again, there can be the cost, time of development of analysis. So time of development of analysis, if I'm using software like R and all, I need to write multiple scripts to do the analysis. However, a lot of software like SPSS is now the IBM product, and IBM product, if it is there, they have the GUI as well, along with writing the codes, right? So people who are not very like at a very let's say imagine that some of the executives, they want to see the results by themselves, but they don't want to do the coding and all. They can do the drag and drop in SPSS, in SAS also, in some of the mini tables also, but mostly like SAS, SPSS, these are giving you some of the good GUI where you can do the drag and drop and perform even the model like this, and I'll talk about it. So again, the selection of the tool is very important, and that will definitely play a role in your time of delivery and the ease of building the data prep, either the model building of your any of the problem solution. Yeah, for this project, because I had a very quick time, because the problem statement was, means I want to quickly try and test that what I can do into the agriculture business to, applying analytics, how I can make it more effective. So initial development I did on R, and then some of the rule-based creation, like we use decision tree, which I'm going to talk about briefly. Again on SAS we did. So it's a mix of R and SAS both, and will depend. Like if I have the analyst free on R, then I can do development on R. If I have the resources available for SAS, then I can work on SAS. So it will depend on a lot of things. But any big org will have multiple applications for you to work on. So now, how many of you heard about decision tree? And how many of you like having ice creams? Only few of them. Rest don't like ice creams. Well, it's surprising. So decision tree is like having ice cream for the fun, isn't it? It's like very easy. And so now you have to help me to understand, what do you mean by decision tree? What kind of tree is this? We have seen many trees, right? So what is the tree that is called as a decision tree? Only two nodes, either this side of the node or that side of the node. Fine, good. So the fun is when you know what is the advantage of it, isn't it? Because until unless you don't know what you got, right, you can't appreciate until unless you don't know the attributes of it. So let me help you to understand. There are two kinds of model, you can say. One is called parametric model and one is called the non-parametric model, right? So what do we know parametric model and what do we know non-parametric models? Now, let's say I invite you for a party at my home, okay? And then I say that, hey, come to the party, but wear a hat, red tie, okay, and shoes with white socks, okay? This is my condition. You can come have drinks, fun at my place. Party is without any, like party is sponsored by me, right? How many of you, maybe let's make it like I'm throwing a party at Ramada, and then how many of you would like to join, right? Now the second condition I'm going to give you, come and join the party. Which is better? Second one. So parametric model and non-parametric model, now you have to relate it. Parametric models are the constraint based. They follow a lot of assumptions. If you can follow that assumptions, you're good to build a model. Okay, you're good to use those models, right? Means, how many of you have heard about linear regression? Everyone? Okay. What are the assumptions behind the linear regression? Data has to be normal. How will you check the normality? How many of you agree with data has to be normal? What data? Data will have many variables. If I say that this is my the data that I was talking about, that will have hundreds of variables. Which data we are talking about should be normal? Target variable is 1 and 0, how it can be normal? Dependent variable is the target variable. Dependent variable called as a target variable also. Independent variables are, there are many independent variables. Then which variable? So it is actually the definition is, let me just cut it short, it's the error which should be normally distributed with your model. It's not that the data should be normally distributed. So what I want to conclude with this example is parametric model will have many constraints. And even if you build the model but it is not satisfying those assumptions, those models are invalid. And hardly, like when you will be as a practitioner, you will always do that. But in your maybe exercises, you might be doing, might not be doing. But what do I mean? All parametric model will perform very good if you are able to validate those conditions. Okay, so if you have those set of costumes, it's good to come in the uniform. What do I mean? If you are able to satisfy those assumptions and the kind of constraint, it's good to build the parametric model. If not, then go with the non-parametric model. Is that fine? Okay. So now decision tree is a non-parametric model. So first advantage is this, no constraint. You're going to play free. Now, why I asked having ice cream? So let's say like if I have to know that whether I'll have ice cream or today or not, how I'll take the decision, and whether the person will default or not, how it will happen. So just relate with it. So let's say if I'll have the ice cream, if the day is, what can be the conditions? Give me the conditions. When you take ice cream, okay, if it rains, then you will not have ice cream. When it is when it is hot, you will have ice creams. Okay. What else? In a party, when I have the free availability of ice cream, then I'll have ice cream. Okay, can be one condition. Means I'm in a party, I'll have always ice cream. So imagine certain variables can come in the rule there as well. If the check bounce, the person will default. So I'm just going to connect it. So, okay. Again, when will you have ice cream? It's a very simple question. Okay, if I had the lunch, then I can have ice cream, isn't it? Isn't it? It is just if then else criteria. So decision tree is a divide and conquer if then else criteria only. Okay, and it's a non-parametric equations, non-parametric models. There's no equations. Okay, now I'm going to ask you quickly one question. I'm going to write two equations here. Oh, we got 20 minutes. I'll just. Okay, so I have written an equation y is equal to m1x1, m2x2 square, m3x3 cube plus dot 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 mn xn to the power n. Okay, and second one mn xn. Okay, can you read these equations? Here is the degree of the equation is increasing, and here it's linear, right? So which is the linear regression? The second one. How many of you say only second one, and how many of you say only two people? How many of you say that first one is the linear regression and rest are undecisive, or you're not able to take decision? Okay, my question is very simple. Can we look at it? It's m1x1 plus m2x2 plus m3x3 dot dot mnxn. This is the second number equation. First one, the top one I have written m1x1 plus m2x2 square plus m3x3 cube plus dot 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 mnxn to the power n. Second one is the linear, right? How many of you say first one is linear? Linear regression, can be linear regression. No one? I'm asking, how many of you say second can be the linear regression? All of you? Who is not? No one, right? Now, my second question is, how many of you say that both can be linear regression equation? Anyone? No one? Okay. Oh, you are saying, then you have to tell how. So, first one I have just intentionally put the certain degrees, okay? But this is variable. So, just think about this, my friend. So, let's say like it is, what I do, x2 square, I'm just writing x2 prime, okay? x3 cube, I'm writing x3, I'm replacing, like you have all learned in your some simple maths. Let's say x square is equal to y. So what do I mean? Actually, it is again the question about the assumptions. So actually the linear regression is not about what is the degree of the variables. It is the linearity with respect to their parameters, which are the m's. So now you can understand the complexity that when you build the, the parametric model, you should have. So this is another constraint of the linear regression which we don't consider, either we don't validate always. But even if you might have built the good models, but that is not valid because you have not followed the required party rules, what I put to invite you, right? But in the case of, again, decision tree, it is non-parametric, it is if then else criteria. It is like when you want to have ice cream, right? So it is very simple, and without going into the too much mathematics, you can basis the if my overdue is for this many period, if my some of the product type of this I have taken, I may have the higher likelihood to default. And as it is called as a decision tree, it will have a top-down form of the classification, like you will have a parent node, and out of that there will be child node classified under this, and you will have a, so what is the variable here? The size of the tree. I may have the 5 levels of, or the layers of the tree, okay, like this. And this can be like this. So somebody can stop the tree here only, somebody can stop, take more trees. So this variation will change the accuracy of your, or the power of your model. So again, you have to have now control and the try and test that what is the size of the tree can have the better predictive ability, right? So these are the few things that you need to consider. And in this case, like again, like I used some of the decision tree model to give the rules that who are the dealers having the high riskiness. And again, business applications, I have discussed some of them. You can read about it quickly. It can be for the customer churn, it can be for the build and buy decisions, it can be for customer propensity to even purchase any product or default, or bank loans default or sales lead qualifications. So there can be many. I have given you some of them as an example. So ROC is called as a receiver operating curve, and when you build the model, you can always plot the, so at the x-axis it is called as a, so there is a concept of sensitivity and specificity. Sensitivity, the blocks that I plotted. So sensitivity is something, when I say you are a defaulter, model is also saying you're the defaulter, right? So it is like a identifying event as an event, okay? Now, identifying non-event as a non-event. So this is a two strength. If I'm saying you're non-defaulter, and model also said that you're non-defaulter. And what is the deviation? If you're a defaulter and model is saying non-defaulter, is this deviation. So saying the event as an event and non-event as a non-event. So event as an event is called sensitivity, and non-event as a non-event is called specificity. When you will plot the sensitivity on the y-axis and the 1 minus a specificity on the x-axis, you'll get an area, right? And this area will look like this. Higher the area under that curve, that the y is equal to x line and the colored line. So I have 3 models. The model which is giving me the higher lift or the higher area under the curve will be the better model. So higher ROC, better model. Okay, so these are the ways to monitor the fitness of the model. That is what I have talked about. Confusion matrix, that 2 cross 2 matrix is called confusion matrix. ROC, area under the curve, you know what is sensitivity, you know what is specificity, and you will learn more in detail in your curriculum. Okay, so now if I have built the model, then I created the sum of the, now imagine that for every dealer we will have a risk score, okay, and in the risk score we will have a certain, when you will now build the model for every dealer, we will get, let's say 0.789 is for you, 0.234 is for you. So this is a probability to default, but it is very difficult for business user to understand. So what I did, I can multiply it by 1000. So what it becomes, it's let's say 789 for him. 0.789 becomes 789, 0.234 become 234. So now I can give you a very simple rule that higher the number between 0 to 1000, more riskiness, closer to 1000 is more riskiness. So now any literate person can say that, means person X who is having score 789, like closer to the 1000 is more riskier, 234 is less riskier, isn't it? So I basis this model, like every node will have its own risk score, the probability score, which will be in the decimals. We can multiply it by certain numbers. I did it by 1000 and make it on a 0 to 1000 scale number, and closer to the 1000, more riskier the number, and you will avoid putting more inventory to those dealers, right? So this is how, like, now I can say that any dealer getting the score more than 700 is high risky, right? And then 600 to 700 is so high, very high risk, high risk. Let's say like 3 to 600 is medium risk, below 300 is low risk. So now you can classify them, or you can segment them into the different buckets, and then you can now give it to the business that, hey, you act or you push more inventory to these dealers, you put less inventory to this dealer. This is the scores of the riskiness that you will get. Yeah, how I arrived on this course, right? So as I talked that I did the data prep, you have seen the data what I used. I just merged it, built the data mart of it. Then I had a set of the models. In the set of the models, like I have the options that I can build on the decision tree, I can build on the logistic regression, I can take any of the machine learning algorithm like the support vector machine with the kernel density functions. And out of that, I can try all the algorithms, and basis the best model which is giving me the ROC, which is best giving me the confusion matrix, I picked up that. And when you do these models, the resultant of those models are nothing but the probability scores. So when I'll run this now, that is the if then else criteria, right? So in this there will be no inequation. But when I build the logistic regression equation, then I will have a equation like this. So it is like this, the log of p by 1 minus p. P is the probability to default, and then it is like something like beta naught plus beta 1 x1 plus dot 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 plus beta n xn. And x1, x2 are your variables. Like here, it can be what was your payment frequency and all. Betas are their parameters in the equation. Like you see the equation y is equal to 2x plus 3. So 2 is the parameter, x is the variable. So when you build the model, there is the model's output is nothing but value of these parameters, right? And this value of this variable you will have for every dealers. So when you will place these all values for the dealers, and you have the values of betas, when you will calculate it, you can get the value of p by exponentiating and transforming this, right? You will have all those syntax to do it for you, and it will, at the end of it, what you will get the scores. Does that make sense? Yeah. So now, and I told you that what I did with those probability, I multiplied by 1000, I created on a real number 0 to 1000 scores. I gave them the classification that, and because you have the data, you know that if you make 700 as a cutoff, then what is the risk? How many have them defaulted, right? Basis that you can classify whether you need to put at 700 the cap or the 750 you need to put the cap to say them higher risky above that. That all experimentation you can do, and you can classify them. Okay. Now this is something you can skip. So this is what I was talking about. The true positives is when you are saying defaulter as a defaulter, true negative when you are saying non-defaulter as non-defaulter, and that is what I said, sensitivity and specificity, and this is how the accuracy is true positive plus true negative by. So let's say if I have 1000, and out of 1000 I'm able to capture 80% defaulter as defaulter, means my model has the 80% chances that in out of 800, if I have thousands I have done the business, out of that only 80% time I'll be able to do the right decision, 20% time can be mismatched. That also can be improved basis the right again fine tuning of the model. Okay. And again, so now once you have built the model, the different variables you can, so the equation I have written, or even in the case of the ice cream, like which is your decision tree, you can get the rank of the variable, that which variable has the highest impact to make you on the default. Okay. So let's say like, what can be the simplest example for you, that let's say like your success in the life is dependent on, let's say 20 variables, right? Which is the most important variable? It's your education, it's your ability to sell yourself, it's your ability to learn new techniques or something, right? So you can rank the variable which is causing you the event, right? And then if business needs to take the decision that how to reduce those events, then we can act upon those variables and we can try reducing it. Okay. And same can happen for risk, marketing, any kind of models. Okay. So this is again like basis the model that what the output I got, and then I represented it. This is what I was talking about. So how the different key driver of the risk that we can get, some of for the sample I have written you, that location, tenure of the, let's say, territory manager, or the tenure of the dealership with us, how long they have been working is the second most criteria. Product category, what they are operating in, they are the product which definitely are more riskier because they drive the high risky business for the even the farmers kind of, so can be that. So now let me help you with this. So this is what analytics. So I started with the problem and we have got the solution, isn't it? Like, you know what you did. You took the data, you did certain preparation of the data, right? You selected out of the best, like some of the available models. You got the best model, you got the scores, you classified them. Now, what else you should do to now minimize the risk? So here I have just done that, not only the building the model, but now you should do the analysis of how is the technology maturity of the business unit for which you are working. You as an analyst should think. What are the functional gaps? So there may be certain gaps also that you need to highlight basis the analysis, that maybe like your billing system is not so efficient, right? Maybe your pricing of the product is not so efficient, right? That can be your product is able to promote well, your competitor is able to promote and the price well, package well of the product, right? So that's how they are able to capture more market and more synergy with their, the vendors and the suppliers, and then they are able to minimize their risk, right? So what I'm saying, the round side of the box is not only the mathematics should come, but your analysis should bring the all-round analysis of the business. It should not just that I have given the equation and that's it, right? So you'll not be able to do the justice with the engagement. So the analysts are not only responsible to build equation, but you're also responsible to bring the holistic view of the entire business. So now if I have built a predictive model for, what is the probability that the dealer will default? Now I should build a model that what is the dealer lifetime value. So let's say like you all are dealer for me now. So you all will have a different value for me. And let's say if I have to segment you under that, who is my most valuable, who is my second set of the most valuable, who is my least valuable dealer. So that if I have to design certain policies. So I can predict basis your certain business inputs variable I have, I can build a predictive model to predict what I'm going to earn from you in the next 10 years. Okay, so that will give me, again, better strategic view of managing it. This I talk, dealer risk score at the time of acquisition itself. So while I'm getting 100 application that I want to be with you for this business, I can build a predictive model like we do for the bank loans, then and there itself, that when you apply, you put your capital, size of your business, the kind of other diversification you have, basis that I can predict, right? And then again, if we need to reduce the risk, then we need to do some of the org change or the transformation activity, which can be like, making your TMs more effective. TMs means territory manager. I mean here, sales executives more engaging with your dealers so that you know the pulse at each and every time, some of the field indicators which you can include in the model for the better prediction. So again, what I tried capturing here is some of the leading and trailing problem statement from the center of the problem, what you are solving. Okay, so you should solve that as well. So I have put the questions here. Let me know if you have any questions.